Welcome. The adoption and use of AI technologies to enhance business and online services has been developing at a phenomenal rate in the past few years. My name is Robert Grupa, and in this session I'll be presenting a high-level introductory overview of cybersecurity considerations for enhanced applications, AI-enhanced applications. So just a disclaimer to begin with is that, AI technologies are really fantastic, and I am in fact very impressed and enthusiastic about the potentials, new uses and applications. But when it comes to providing services and protecting other people's sensitive information, there is a degree of pragmatism and caution that needs to be exercised to avoid any type of future undesirable outcomes. So to summarize, it's a really great tool to use for search results, prioritized rankings, being able to analyze documents, quickly summarize meetings, combining multiple documents together, having a natural language interface to asking it questions to, say, create code or different types of formulas, language translations, audio and video editing, and creation, derivation. In manufacturing, being able to take a picture of a part and have it automatically create blueprints just straight from the pictures. So then those can be used for tooling setups. Pattern recognition for things like medical screening or signal analysis, logs analysis, and then generating documents from outlines and prompts. So documents, code, music, videos, and on it goes. We're always finding kind of new ways to apply this technology. But in the pragmatism aspect of it, at least from a software provider perspective, there's a lot of concern that needs to be given to the shared responsibility model. So that's usually thought of in terms of cloud vendors and platform vendors. But this also applies when it comes to the AI model vendors, the tooling that we use for that. The integration and upgrades and the patching maintenance are extremely important to understand who's responsible for doing what and what the expectations are. Then there's liability. Customer-facing products and services. There's implications for brand reputation when things don't go well. Then there's legal and regulatory compliance that needs to be considered. For internal organization solution owners or product owners, there needs to be accountability there as well. And there is. It's starting to be built more and more into some of the developments in the news that we're seeing and the lawsuits. Also the cost complexity. So we're very used to regular traditional IT platforming and hosting and delivery, but now you've got the extra costs of what is that AI going to cost. So right now it's pretty much a kind of free drugs for kids type program, right? So the developers of the models, providers of those, have provided it for free and now are starting to incrementally add more cost to those to try and recoup some of their platforming, hosting costs and development costs as they need to. And we just don't know where that's going yet. In the development itself, that has more complexity to it, and therefore it's going to cost more. The maintenance of these tools, you can't just release software and forget about it. And then the functional monitoring as well that's necessary, that we'll get into a bit later. And biz recovery, what happens when the service fails? What is the resiliency? So in the agenda here, I'll just briefly touch upon some high-level terminology and challenges, application security failures with AI next-gen type products. We'll talk about the threats for AI solutions, the types of attacks, and then get really down to the nuts and bolts, which is the defenses for AI solutions. So what is the risk management governance that needs to be applied, and then also what is the process for developing software securely? How is that different for AI enhanced applications? So AI technology products have been in active development since the 1960s, but they just weren't well known. You had people that were into Unix or had access to some mainframes and things like that, and so they were more aware, and every once in a while we'd hear about things like IBM Watson, but it wasn't really accessible for most people to be able to use. In security, heuristics is what it used to be called before. So the early 2000s, there were security products using heuristics, and up until, say, 2010 as well. In that era, we saw several products from the security vendors. And then in 2012 is when we had products starting to be introduced that were solely based on analysis that the application was doing versus a signature-based detections. And then web chatbots have been around since about 2015. So a lot of these things have been going on, but really for most people's understanding was with Chat GPT 3.5, when that really hit public awareness in November of 2022. So at the end of the year, and it went viral because that was the first time that most people could easily get access to it. Just needed a web browser, and it was free, and really set off a firestorm of marketing hype that has gone on since. And companies looking to grab that bandwagon, if you will, reinvigorate IT spending for products, software, solutions, and being able to differentiate themselves in the market has been a huge driver. But in spite of all of that, really, is that it's been quite a challenge for companies to develop solutions that are integrated and work effectively. So 45% of companies talk about that they are implementing AI technologies, but that it is a significant challenge for them. And then with 38% saying that the cost of the integration or the complexity. But we're still really looking for some kind of killer applications for this. And so Microsoft, even though they provide lots of Copilot and agents and all the rest of it and invested heavily, they're still wondering how much the market will bear as far as additional pricing and what this is going to mean as far as rate of return on their investments. Over the past several months, if we just look at developments going on there, AI is still struggling with mathematical processing and computations. Vibe coding has become the latest hot term for companies, but there are also the concerns that have been continuing about the AI slop, is the term being used there, fouling data and including more vulnerabilities. So far, it really is a great tool for SMEs to be more productive, but not reliable yet that we've seen in any reliable way for unsupported, unsupervised automation uses. Now, usually at this part of the presentation, I like to go over some of the, what are the epic fails of application security with regard to, in this case, Gen AI applications. But there are so many over the last year. Every week, there are just too many to even list. So I have a newsletter, AppSec News Bits, which I'll refer you to. But there are others, right? And in there, they would be all too long. That would take a whole presentation of itself, even if I were to do a look back just of the last 12 to 6 months or even 6 months. So, but just some common themes. Ignorance, naivete, and laziness, if you will, of users and implementers. So some stories in there have been about judges sanctioning lawyers for legal briefs that are written in AI, but they have false citations. Same thing applies in research as well, papers and grants that are being written. And then you have silly things like companies trying to then claim that they can't be held liable for the informations provided by their own chatbots on their websites, giving discounts, for instance, or free products to customers. And then the company doesn't want to pay them. Hacking, we've seen a lot of different focus around crypto theft, brokerage accounts, and banking systems, of course, going after where the money is, then using AI to discover vulnerabilities and then create and execute attacks. That is, technology is being used very well there. But even then, some of the vulnerabilities that are being found in the attempts, they get caught out because it wasn't fully as mature as it should be. But the other thing that the hackers are going after is poisoning the AI data sources and the applications themselves to gain footholds. FBI has been warning about the increased threat of cyber criminals using artificial intelligence technologies overall. Several different alerts again about that and reminders. Supply chain attacks. These are through the components that are used to build the software and even the tools themselves, such as the IDEs, the integrated development environments that developers use to write their code. So those have add-ins where you can have an AI agent help you do the vibe coding and help remediating issues and suggesting code. But also some of the code that's being put in there either is very poor quality sometimes, and then also sometimes it will include malware. So not all bad necessarily. I mean, it's a great tool to have, but people need to be aware, because when you're able to move at these speeds and productivity gains, doesn't mean that they necessarily understood all the nuances of a big block of text that they are just cutting and pasting and go, hey, it runs, it appears to work, let's release that. Then there's fraud and scams that are just continuing to increase. Financial theft, again, using real-time telephone and video deepfakes. So these are of business partners, people that are known by others in real life. They're attacking business contacts for business funds transfer, and also customers, consumers are being hit with being called by close family members that they trust that seem to be in distress or need assistance, and they hear the voice, they maybe even see and talk to what they think is the person in a video, and it's all being accomplished through real-time AI fakes. So a misappropriation of the technology, but also when it comes to business processes, then how do we defend against those? How to detect and defend against those? Then there's AI generated content. There are a whole bunch of, say, copyright questionable issues. There was a musician, for instance, that's using AI to create whole playlists and made up songs and then earn royalty money off of that, which is not ever the intent of those platforms. So some of these content platforms are paying money for information that may break copyright because they don't know the true authorship of them, and also to unworthy sources. And they have the similar kind of issues going on with grants, government grants or research grants, where the number of submissions is going up because they're automated and the citations and the reasons are not necessarily valid. Then there's hallucinations or conflagrations of the AI itself, causing reputation damage. So this is at a personal level as well, where you may ask an AI about an individual and it comes back with false information. There have been several different stories about people's profiles claiming that they committed crimes that they never had. Or then you have monitoring, AI monitoring, where it is accusing children in schools or in other environments of wrongful acts, breaking the policy of the schools, if you will, for posting inflammatory posts or that they had images that shouldn't be allowed. And yet those things were false, so they're being falsely accused, and it has resulted as well as children being imprisoned. So anyway, these are some of the stories that come up, and again, too many to really list out here because they're every month. Fill a whole screen. When we look at what about companies, how do they feel about their confidence in security? And really, this is just one example of a study. There are several like this, but COBOL's State of Pen Testing report, I'll just pull out here, shows that 85% of security leaders will respond that they are confident in their security posture. But realize that this is self-attested, and it doesn't mean that they understand all of the nuances of the threats, the attack types, or even that their organizations, do they have the right type of defenses that they need, the things that we'll talk about later. And despite this, where they do have visibility into vulnerabilities of their applications and things like that, then 31% admit that the serious findings that are discovered are not necessarily resolved. So that's of the ones that they know about, right? So these are where they have scanning or some testing that actually takes place. But what percentage of their environment is not tested? So what's the confidence in that? It's another thing that needs to be considered. Too many findings are left unresolved. And then when we talk about AI vulnerabilities, 95% of the companies will talk about pen testing their applications at least once in the last year. But a lot can change. There's always releases going on and products being active released. But the vulnerabilities that they find, not all of those are being fixed. And when we talk about things with large language models and web applications, then it just amplifies that whole risk. 72% rank AI risks as their number one concern ahead of third-party software risks. But as I kind of pointed out earlier, a lot of the third-party software risks are still prevalent in the AI attacks as well. You'll see that in the list of different attack scenarios. So while it looks like over half say that they're well equipped to address the security implications of Gen AI, looking at some of the attacks that are taking place, it is questionable, and it's going to become an increased problem here overall as the attack surface overall increases and the cost of security there's that pressure within the organizations to contain it because their budgets have been based on previous non-AI development. That's what their kind of costing models are based around, and yet it's still, we don't have the history, if you will, to figure out what is the appropriate need for that in the long run. So some short terminology and concepts with regards to AI and LLM. So artificial intelligence really goes back to simulating human intelligence. Machine learning is about these systems being able to learn from the data that they're able to access and then to improve their own performance. Large language models are trained on large data sets to try and then generalize and understand the content. Generative AI is the piece that then generates new content, creates new content, so text, images, sounds, based on the patterns that it's learned about in the large language models and machine learning. And then a subset of that as well is the retrieval augmented generation. So the way I kind of think about that is AI assisted search, where it's given a particular set of parameters, a hosted data set, if you will, and you can use the natural language interface then to query it before it generates responses based on that knowledge. So this is a typical diagram that would show the elements in here. You have your data that is used for your training. You have training algorithms that go into the system. You have a foundation model. The foundation model is the neural network. That's kind of the secret sauce, if you will, that learns from the context and develops the relationships and meanings that it has in its associations, like analyzing sentences and blocks of text and patterns to develop correlated context and categorizations. And the transformation models are mathematical techniques that are applied with the model itself to then create various other types of content and interfaces. So you have within the model here, you have the tasks people are looking to do. So answering questions, being able to look at the sentiment of the user. Are they happy or are they sad? Are they distressed? Extracting information, capturing images, and so forth. Now the challenges in these is that the LLMs in themselves don't always really know what the context is, that it's trying to make associations based on probability models, but it doesn't have any common sense. It's not like humans where we understand cultural differences in communications that haven't necessarily been written into an actual formula somewhere. So slang words and usages change over time, either generationally and also culturally. The machine learning, it's not deterministic. It's not in a if A, then B, and then C, but rather it's based on probability associations. And then it is also susceptible to hallucinations, where it's trying to choose what it thinks or is experimenting with is a best match. And the other thing is, because it's learning about what works and what doesn't, it doesn't unlearn or forget what it has tried before, or if it's using corrupted data. So the other implication of this is that even after post-deployment, the system is continuing to morph, if you will, and change. So it requires continuous validation and monitoring. And therefore, it also becomes extremely difficult. You can't just go and say, well, we're just going to do a clean reinstall back to the base image, because you've lost all that information that has transpired. And so do you know where that cutoff point was, and can you even get to that place? Now, the developers, have all the best intentions. What could possibly go wrong? But who decides what is right, what is wrong? So no matter how altruistic and logical programmers think they are, all humans are susceptible to some sort of human weakness and opinions and perspectives. So these prejudices really go into the application, and these things are called the biases. And so there are many different ones in here that I will not review here, but you can look them up. And these are all things that machine learning computer scientists are really struggling with and trying to figure out how to address these and not have them over amplified in an unintended way. So again, I've mentioned deterministic programming, and you can have, historically we're used to software operating in a reliable way that's repeatable. We write unit tests, integration and regression tests to always give the same kind of results. And we can pass or fail it at that point, because we know that we have a use case and it's going to come down to some branching point and it'll make a weighted decision or whatever. But all of that mathematics and the logical processing is reflected in the code itself, and it can be examined, and we can run data through it and compare it at the end, right? You can create a checksum, run it through the application, and make sure that it is coming up with the correct answer. But when we talk about machine learning, these adjustable algorithms in this neural network here, these nodes can constantly shift and change. And they will begin to change not only the algorithm inside it itself, but then its weightings that it applies based on the various branches. So it looks for acceptable ranges instead of correct answers. And you can ask it the same question and get the different answers based on just the time of when you ask it. So these are, again, very problematic because, again, we know that they're human designed. We think that these are deterministic, even though we understand that there's some secret sauce in there. But that key understanding of what's under the hood is extremely important to recognize. So the hallucinations or confabulations seems to be a more current term, maybe, is really a part of that statistical analysis, and it's an inevitable byproduct how it's trained. So what causes the hallucinations themselves is the error in the encoding of the data and the decoding. So those transformations itself, sometimes it misinterprets information or it has data sources that weren't anticipated. It's also being trained to provide different diverse responses. And then the training of the data set may not be labeled properly. So a lot of how that data is absorbed and then later referenced. So it's not always rooted in just looking at discrete labeling. The large data sets also create a problem with the parametric knowledge. The larger the information it is, the more the variability it is, and the hardwired information and analysis of it can be more variable. So, yeah. And then talking again about the unreliability or the unlearning and forget. So training data that then somehow includes confidential or sensitive data. So if the data gets in there some way, and there's many ways to insert it after it's been trained, or incorrect data, just as bad. Like a quick example, if I were to say 2 + 2 = 5, and it were to be reinforced to the place to where it begins to believe that fact. And then malicious data, of course, where somebody is actually putting it in on purpose. So that is what then as it learns, it has a difficulty then unlearning that. How do you restore it back? So in recognition of this, NIST, the National Institute for Standards and Technology, has a risk management framework for AI. And you can see these elements here that I've just mentioned as well being applied there. So whereas before we were talking about what did we know about AI security or AI implementations and their shortcomings, if you will, but NIST is highlighting them again in here for the security practitioners, that the privacy risk, the statistical uncertainty, the bias of its findings, and the reproducibility and computational costs are all things that is security, cybersecurity organizations and professionals need to be top of mind. When we look about the overall impact, we've talked about IP theft, but that has to do with organizations looking and individuals looking to protect their own. So from plagiarism, how do we protect homework and research reports, journalism reporting? These are all activities, if you will, that would draw from copyrighted material maybe and then plagiarize them. We see many examples as well as in the entertainment field, the writers, comedians, and musicians, actors worried about their likeness and the types of the styles of their performances. There's also reverse engineering of technologies. So it can imitate what the copyright is or the patents. And this is of concern when you have nation states that are competing internationally. So you have various competitors across the international board, each one of them looking to use and concerned about using AI technologies overall. And cybercrime, mentioned the whole phishing. So despite AI being applied to spam and phishing for decades now, we still are struggling with what to do about that. Vishing is the new thing kind of this year that's cropped up a lot more, of where it's voice calls. Vulnerability discovery and malware, again, we're beginning to see that. Looking at some of the recent conferences, accounts payable fraud, I mentioned before, business email, and account fraud, and social media bots can be very lucrative for the cyber criminals. They again have a whole economy and infrastructure where they have different crime groups developing tools. And so just one example is that if you run a social media bot, you have the technology for that. You can rent it out to other people to abuse and use with humans. And so they can make over $14,000 a month on those. And then generating fake IDs is a whole nother business for them as well, from harvested PII data. Spying and looking on personal monitoring of devices, hearing our personal speech and behavior, and reporting on that, either incorrectly or not. Like the father who is posting pictures of his skin condition, being reported for pedophilia by the system. Maybe that wasn't AI, but it's still an issue. We have other things like the children I was talking about in schools as well, or students in general. Then the web information itself, with all the misinformation going in, then fraudulent websites being created that are typo squatting and using DNS poisoning and SEO poisoning and all these other techniques to be able to change the truth, to put out misinformation, the explosion of derived information and unreliable information. We see that in news stories that get generated and then later pulled, realizing that they're not being factual. This is being used for propaganda, pressure groups, and to provide non-expert trusted rankings, all sorts of shenanigans. The AI trustworthiness is really at question there as well, because it's down to the biases of the creators and the implementers of these systems, and the data that's used, and whether or not it's been polluted by other AI generated content. Then, so where have we seen the highly anticipated wins? Kind of like the Microsoft comment about what is the killer app out there. But in IT, the security challenges are still there. We haven't seen any reduction in malware, in spam, phishing, or attack detections. If anything, all these threats have increased. And then if it was so great at all of its other knowledge, then how come IBM isn't, say, the best stock, the most valued stock in the world right now, since they have all that business strategy consulting at their fingertips? The stock market day traders, I haven't heard of any yet that have become billionaires using AI tools. And then the medical cures. There are all these moonshots over the decades where nations have tried to pour tons of money into coming up with preventions and cures for things like HIV, COVID, and all the rest of it. And again, these still elude any of these technologies. And if we look at the tools, started off free to build up a lot of interest and excitement, but now if we look at, say, the Microsoft Copilot, that's going to run about $360 a year, the introductory pricing. We don't know if it'll go higher. OpenAI increasing to $2,000 a year and more right, for some of these professional PhD level subscriptions. So enough of that, kind of the background and state of Gen AI overall. Again, some negative things, but definitely cool applications out there, and a tool that nobody's going to want to give up. Doctors, for instance, that even though they understand all the hallucinations and the wrong diagnoses and all that, still find it useful in medical practice. And I think many of us in other professions would say the same as well. We know enough about this content area, and we can evaluate when it's off and on acceptability. Now, when we look at AI security as a whole, just to give you this kind of a diagram showing all the layers that are involved in not only developing and delivering and maintaining an application in the computing stack, but also then in this overlays as well for security, because the attackers will look not just at the surface, not just at the web interface, but how do they undermine the underlying more basic layers, say in the OSI model. How do they leverage those as well for their attacks? And with all of this, so as a security, we need to address security at each one of those areas, which is a tremendous undertaking. But then there's the new legal footprint as well. So I listed off some of the different laws that are being used to look at and evaluate the usage of AI technology enhanced applications, but this list grows almost monthly with either new proposals under consideration and also new ones being passed. And we have a lot of, in the United States, for instance, each of the different states looking to come up with their own guidance as well. So this has become a whole huge area for companies looking to provide commercial applications in various regions and geographic locations. Now, for attacks and threats, what we usually think of there for standard applications and IT systems, MITRE has their attack framework, which is what, if you haven't seen this before, this is what, say, the red teams, the penetration testers, would use as a guidebook, if you will, a map of how you would infiltrate an organization and then get control of systems, exfiltrate sensitive information, and do damage. So all of this here just applies to standard IT. And when we look at these as well, these are all multiple paths. So you look at, from a security perspective, a chain reaction across, and it's the weakest link that will be able to exploit the system and unlock the lock. And so for this, there are many critical paths that can be taken through this based on wherever the weakest security point is. So it's not specific to just applications, but when we talk about AI, then you have to apply these same considerations. Now, for that, MITRE also has come up with a version for machine learning attacks. So on the model itself, right, we have the application, then we're going to take these new components, and now these can be attacked in novel manners or specific manners. And so they have an attack chain as well here to show that if you're an adversarial attack group, or if you're looking to QA your application, what are the types of test scenarios that you need to have, and what do you need to try for these? And in their guidance, they provide case studies as well. So each one of these, sometimes we may look at these and we go, oh, well, that's not really real. That didn't really, did that bring the downfall of a whole application or a company's vulnerability? And so they've been maintaining as well. You can go read the case studies on these about why these are included in these type of maps, the organizations or the experience that was found in the analysis of the compromise of various systems. Now, the Open Worldwide Application Security Project is a nonprofit foundation that's been around since 2004. And they originally started off with looking at web applications in browsers and APIs as well, but mostly browser back then. What were the common attacks that were being used, and then so that there would be awareness and ability to protect applications against those types of attacks. And in doing that, what they have is a series of, they do every few years, research with questionnaires and looking at industry data overall about all the kind of information that's available to different attacks. And in their process overall in here, they start off with, well, you've got a threat agent out here. They have some business impact that they're looking to disrupt, if you will, or change something. And what they are looking for is how to find weaknesses within the infrastructure and the application so that they can get to control, past the security controls, how they can avoid those to then get into the business technical impact functionality. So, and from these, the data, they rate these on how exploitable, weak, or how prevalent it is, the detectability of the weakness, and the impact that it would have. And from this, they can come up with a scoring then to develop their list, a prioritized list of what the top threats are. Now, they do many other projects and guidance. So over the years, this has grown immensely, as you can see here. From this, these are all the different types of projects they have. And what I was talking about there is the top 10 list, which is what a lot of people just think of. They think it's one list. And the one that they had started off in here was the top 10, but it's for web applications. Now, this one, even though, as I mentioned, every few years they go through an update. So the previous one was, say, in 2021, and that was updated here this last year to provide a new set of the top ones. And also when they change these, the terminology will change as well over time. So it's not a static type of categorization. We've also had additional ones such as the top 10 APIs, so 2023, cloud native applications in 2022. You've got the top 10 for mobile, which was updated here in 2024 here toward the end of the year. So in the last year, if you will, 12-month period. They have as well a new one for non-human entities or identities and large language models here. This one was updated this year, previous one in 2023, since we're talking about AI application security here. And machine learning one came out in 2023. So all that to say is that for when we talk about overall application security with AI, you have to look at all of these and also look at kind of what is the current guidance and elements from these as well. So they provide a lot of great information, the additional tools and guidance, cheat sheets, requirements, drafts, testing guides and tools, recommendations, and on it goes. So here's a bit more detail on how the OWASP top 10 for the large language model and the machine learning look. So going back to that diagram of the models and the training data and the user and the tasks, you can see in here the similar placement here for where each of these elements go. And then in the top 10, you can see that they have some of the similar information. Like they both have the idea about data and model poisoning as an example here, and prompt injection or input, transfer packages, model skewing. Slightly different, but also some overlap in there. So in this as well, I'm going to review here these together, and we'll look at the attack vulnerability risks for both that kind of address both of these topics, but would be in a common system. Now, to cover all 20 of those would take a long time, so I'm just going to talk about them very briefly for visibility, awareness at this point. And in this presentation, you'll see me skip a whole bunch of slides, but they're in there for reference. And of course, there's the OWASP documentation for even more on that. But in the interest of time, just going to summarize these. So looking at here, the first category for input type attack surface, you have in here where on the task or the user interface, if you will, you can have an attacker here, or it could be a user, and it could also be the APIs. So the machine interfaces as well. And the attacks here that are covered and detailed are prompt injection and an adversarial attack for the machine learning. Now, the important thing really too is, well, the reason I'm not going to go into a lot of detail in here is because as a cybersecurity professional and also or within the organization as well, we're interested in defending against all the different types of attacks, and also from a developer perspective. So we want to categorize what are the important elements that need to be addressed in our defenses to then mitigate any of these type of attacks. So you can see in here that the primary defenses used here in this case would be controlling access control. Also input-output validation. So you can hear as well in these that these are traditional programming techniques that are supposed to be there in any case for any type of software. And then monitoring and alerting. All that's really different here when we talk about AI is that the attacks are on different components, they manifest themselves in different areas of where they're attacked, and also the output and the impact that it will have. But it's pretty much the same concepts overall. So it is accurate to say that AI security for applications isn't anything new. On the other hand, its application, because of the technologies, is all brand new. So with that, here's an example. Again, I'll be skipping most of these, but just to show you what's on these slides available. So talking about the prompt injection attacks, right? Either from the user input or the multimodal injection, so people taking images within text or text within images. Then some of the different examples of the prompt injection, so trying to get disclosure of sensitive information about the AI system or individuals, trying to get it to execute arbitrary commands, manipulating the decision process, and on it goes. And so with these, there are many different examples of the attacks that are provided, like code injection here can happen, payload splitting, all these different ones, again, to show how they can be compromised. And then the prevention guidance here is, constrain the modeled behavior, define and validate expected output formats, implement input and output filtering. Again, we've heard these before for generic application security. Require human approval for high-risk tasks, which is kind of specific in this case, because we can't trust the model to repeat reliably. And down in here, we have, again, the defenses. So we want to be able to capture what these preventative methods are and provide guidance on those within the organizational application security coding standards. And those would be in sections D3, D6, access control, input, and output. By the way, the D3 and 6 and stuff is not a standard designation. I'm using those for convenience to call them defenses 3, 4, and 5, right? But etc. You'll see these here further. So here's an example. I'm going to skip the adversarial attack slide. Another one in here shows detail where it's trying to poison the information by giving it confusing pictures. Is that a dog or a cat? And again, you have the slides to look at. Output attack scenarios. So in here, what we're looking at is the application and the security model overall regard to the user themselves. So they're interacting with this system, and is that bias then going into synthesized content that is then getting put back into the training data? Or in here, the output here is being attacked. This would be, say, an API interface where the transformations and the processing logic is then being used by other applications with other further downstream users or impact. And so there are a number of different attacks that are highlighted in here for machine learning and for the large language model, sensitive information disclosure, improper output handling. So that's very important. A lot of times we think only in terms of input. Well, if the input was okay, we know that deterministically what the output would be, but with AI you can't. So there's an increased emphasis on output handling as well. Excessive agency, so what are the permissions and the abilities of the model itself, and has that been exploited? And output integrity. Again, going back to defenses, traditional stuff, access controls, input, output, monitoring and alerting can prevent these. So we'll skip here the slides having to do with each one of these elements here that we just briefly summarized. And now we'll talk about training attacks. So in this category, talking about the training of the model itself. So if we want to be able to poison the system in here, right, get it to, there's focus real on the data itself and the model. There's a membership inferences attacks. These have to do with maybe the system is not allowed to provide confidential information about an individual, but it does actually have access to the individual underlying data about it. So we trick it into being able to provide that information. And then transferred learning attacks as well. And you can see pretty much the similar categories as well, but you talk about data security in here as well, which has to do with encryption, data at rest, and its access control models as well. We'll skip this one here and the data poisoning, membership details. Now the next category of models or attacks would be attacks on the model itself. And we can look at the number of OWASP common attacks. And again, remember that these are categories of stuff that has been seen in the wild. It does happen. So vector embedded weaknesses, misinformation, modeling inversion attack, model skewing, neural network programming. And we see here, again, the different types of categories that we can prevent. Going on vector, misinformation, model skewing, etc. So another category of attacks, insecure design. So this can come about through things like the supply chain. Where did each of these components come from? Are they trustworthy? We thought we were getting them from a trustworthy vendor, maybe. Maybe we got them somewhere and we just thought it was really cool and we started to use it. But what about the subcomponents, even with those? So that's where it gets into things like corrupted packages. These can affect the model, the learning model itself, or the system. System prompt leakage is another area of an attack type, unbounded consumption. So in here, what really protects is the overall secure software development lifecycle, kind of the foundational processes, using things like continuous software compositional analysis scanning and implementation settings, and then using frameworks, trusted frameworks and components, and then logging and monitoring and alerting for any changes that are unintended or anticipated. So supply chain, again, not going to go into this, but this is a huge area. This is becoming extremely popular way that the attackers can get into organizations, because they'll go out and attack, say, an open source library that's then used by 2 or 3 other different applications that are put into a model. The model's trusted, it comes in. So it's the whole Trojan horse story all over again. And so instead of trying to go through the complicated scenario of trying to wheedle your way in through the MITRE attack chain scenarios, you just have some malware that you can insert somewhere into the supply chain and be able to have that delivered, and then you can leverage that from there. So it's a real favorite of the attackers. Corruption packages, similar concept, and system prompt leakage as well. So looking to get sensitive information that's exposed, exposure about the internal rules that were built, being used as guardrails by the system. How can they be exploited further, and the filtering criteria that it uses. So looking to learn about the system from the prompts itself. And then unbounded consumption really has to do with making sure that the system is constrained so that it isn't able to just use up all the resources that it has at its disposal, or it's able to process unintended type of requests. This can result in economic loss, things like the model loss itself, and service degradation overall. So all of those types of attacks, and like I said, those are hour-long presentations in themselves to break them all down, to explain what is happening and the different nuances of how to protect from them. But overall, you could roll all those up, and the bottom line is that if you have strong security practices and tools in place, then you're going to already have protection against these variations as well as future new developed versions. For the most part, right? There may be something brand new and novel, but most of these, when we look back on them, is just old attack scenarios under a new skin. Now, the National Institute of Standards and Technologies has been doing a lot of work in the last few years as well on these. So within cybersecurity, there's the NIST 853, which goes back to 2005. And the latest version of that was in 2023. Building on that as well, or in conjunction with that, NIST has the cybersecurity framework, which is now on version 2 in 2004. But originally they had that, came out in 2013. So most of those really set up the basis framework that companies use for developing their governance and their security controls that they implement and use and validate and comply to. In 2022, the NIST 800-218 came out, which was for Secure Software Development Framework, which provided mappings to the 853. So you have down in here, framework for how should you develop software security as a practice. And this is really important to realize that this wasn't just, say, for governments or whatever. This guidance is for any, not only software developers, like off-the-shelf commercially available software, but also intended for internal development teams, and irregardless of the size of the organization itself or the maturity. With the prevalence of AI technologies hitting the common knowledge, if you will, and the hype that has been built up subsequently in 2023. So very early after the ChatGPT, whole explosion, they came out with an initial risk intelligence framework to be used for AI applications, and especially considerations, right, that go on top of these more traditional application development. Then in last year, the Secure Software Development Framework guidance for generative AI and dual use foundation models was published. And this is really to extend the SSDF, right, the software development framework over in here, to practices for AI model development. So this is not only for AI model producers like ChatGPT or Gemini, any of these other models, right? But it's also AI system producers. So these are individuals that create software that leverages one of those. So the integration software. So this is meant to apply here and provide guidance as well. So it's not specific to AI researchers and products. It's anything that then takes AI technologies and incorporates it. Then we've had in 2024 as well, the AI risk management profile, which came up with over 200 recommended actions across 12 different risk categories. So these again are tools for security compliance organizations to use and to elaborate and strengthen their security guidance and requirements and controls within their organization utilizing AI technologies. And then there's the AI 600-1. So this is additional requirements. Oh, that's the one we just talked about. And then control overlays for secure AI systems. This is for 853 type controls that apply for AI systems. So again, providing that mapping back to the whole 853, which is what many organizations use as a baseline. So that is here rather recent here, just in this month itself. So brand new. And the other thing that's being worked on as well is to go along with this 853 is an update that would tie into the security framework, cybersecurity framework 2.0, that's again used in conjunction with these, and that's currently in draft mode and will be out in early part of next year. In the guidance as well, just to state, these has a lot of commonality. The NIST framework provides crosswalks to other international frameworks. Again, many countries are working on these type of problems. How do we secure these? How do we mature our overall software development within our countries and our regions and internationally? So there's a lot of the same kind of information being presented in various forms out there, but also then it enables companies and organizations to be able to show international compliance with these guidelines as well. So here's a quick just kind of overview of, well, what is in the NIST AI 100, which is the framework here. And what you can see here is that they're indicating in here the life cycle management here. So planning and building and design, doing more of kind of your data analysis, your choosing of the model, you're building your model, so you're doing your coding here, you're validating, you're doing your task or your QA and test, you're deploying it then into production, then you're monitoring it within the production environment, and then you're also looking upon its impact upon users overall in there. So overall, the objective here with this framework and calling out the AI specific elements that are necessary for this is the objective here is for providing safe, secure and resilient applications with privacy enhanced, not being harmful, and yet providing accountability and transparency, and very important here, being valid and reliable. When we look back again from an application development perspective as well, the 800-218, which is the Secure Software Development Framework, that here, again, looking at kind of the software development, you can see in here preparing the organization. So pre-planning, if you will, or what the organization needs to have here identified security requirements, libraries, roles and responsibilities in the organization, tools selected, what are the types of checks that will be done of the application. Then you get into protecting the software itself as it's being developed. So how do you protect the release integrity? Will it have a software bill of materials? Then as you produce the software itself, making sure that it's having threat assessments and risk assessments. It's using the good old trusted components, practices again in here that are secure, that code reviews are happening manual and automated. So don't confuse vulnerability scanning using tools with actual code reviews. They're different because humans are able to outperform any vulnerability scanner to date, and also there are a lot of false positives in there, so you need humans in there to be able to conduct those and to remediate and prioritize the issues. So anyway, this whole framework, and then talking about as well, what do you do about the vulnerabilities, how do you manage those? So all of this is kind of outlined in the guidance here again in the 800 218, and then there is the new version as well, or the addendum that is the A, which addresses this for artificial intelligence applications and considerations. Now, all of this together, it's kind of like, oh, so how do you kind of combine it and use all of that, right? These are all practices in different aspects. Well, for that, you want an organizational secure software development framework that includes your own organizational secure coding standards and best practices, right? So what does it mean? Who does what and how in your environment based on your tech stack? What is the delivery process? Again, who's going to do what and when? And then you've got your testing, what, when, and how. So what tools, are they manual? Which ones are automated? And then key to all of this as well as training, so that there's awareness of these resources that are available and these requirements and what needs to be done, so everybody understands the effort and the reasons behind them, as well as what to be able to do. So taking those in the secure coding standards as a whole, it would be, well, there's a lot of different things you saw in those attacks where they were talking about the different ways that you can prevent them, but that's a lot for a developer, development team, or quality assurance or security assurance to be able to digest. It's like, well, how do we know which ones to apply? Now, in the security professional world and organization, they'll kind of map it to their security controls, which is a bit archaic. It kind of, well, not archaic, but it's a terminology that isn't used by the developers, the software engineers themselves. It's kind of like, we don't know what are you going on about? And NIST 853, number 583, requirement 732, right? These specifications. But they need to know how to find what do I need to do to build things. So you have these different defensive categories. So the first part is just your processes and your frameworks. So you have your category 1, and in here then you can put in here these different guidances, like use the library of secure design patterns, known and approved by the organization. It has the requirements with the user stories, pass or acceptance criteria, and the tools that should be used, when to engage with the security professionals in the organizations, all of those type of requirements, ensuring patch management, right? All of that is in the processes of building and delivering and retiring and restoring applications. Then you have the frameworks and components, right? So as an application, what languages, coding languages are preferred, which ones should be used, and you want to choose things that minimize bug classes, vulnerabilities. Also the trusted sources, where do you get these things from? You don't want everybody just going on the internet and grabbing a copy of something labeled, let's say, Spring Boot, right? Libraries. It's like, are these actually the real ones? Monitoring the libraries and components that are unmaintained, looking for, are there vulnerabilities in these? So anyway, all of those kind of topics. And in the access controls, so here this one has zero trust. You're going to specify what that means. You're going to put in requirements for rate limiting, for instance, of the access and authorization attempts, things like that, the meta tagging and data that's required in your repositories, and then who has access to what, all of those type of requirements of the users. What are their proper permissions? What happens after something, a process terminates or logs out? You have communications, so that has to do with all the connection points between systems at those different layers, right? The communication layer. So you want to make sure all data is encrypted in transit, secure directives to the clients, things like that. Data stores, really about the data at rest, making sure that where you have sensitive information, it's identified. How do you do that in your organization? And what are the encryption algorithms that should be applied, right? Everybody just can't roll their own. Which ones are needed by the organization? What are the roles and responsibilities of the key encryption key manager, custodians, things like that. Input, output, you see prompt injection attacks. This goes back to SQL injection and all the other kinds of input, and also the output. So validating those, what are those requirements that are needed whenever we have a user interface or an API interface? And then logging and monitoring what needs to be exactly logged. So that's a key. Not just that you have performance logging and monitoring, but what are the security events and things like that. So all needs to be spelled out in there to ensure consistency. So you have several different categories in here. You may in your organization have different ones. That's all fine. But again, all with the idea of making it easier for developers to be able to access and then utilize. OWASP also then has guidance regarding the pipeline itself. So you have the DevOps guidance in here, which has to do with the overall application planning cycle as well. It looks like the SSDLC, right? Which it is partially as well, but then you also have your orchestration pipelines as well. And this is a view of the OWASP guidance with regards to also another view of life cycle. And so you can hear in the planning stages as well. So they call it the LLM and Gen AI SecOps framework. You pull up this document, provides really useful reminders here about the different types of testing tools that would be used here, securing the pipeline, right, deploying it. And then also what's important to realize as well, going back to that operational aspect. So post-deployment, what needs to go on in there. So you can see here the repeated emphasis on prompt security needing to be monitored, and the guardrails themselves and other information. So very useful tool, again, to double check either your existing secure software development processes or to develop one if you don't have ones already. Going back to looking about, well, we're not done just with releasing the software in the application, and the team can then move on to something else. Software anyway doesn't work like that. There's a saying that software is like fruit that rots over time, and the same thing applies that is seen with machine learning tools, is that, you know, when it first comes out, it's really exciting, right? There's maximum business value, but then as time goes on, and if the model begins to drift, then that causes issues. So it's important to have the statistical analysis in here of what needs to be monitored within the application itself, looking at things like the data quality itself, the data features and drifts is what you're looking to being able to detect. You're looking at outliers in the responses as well. and the model. So there's data drift and reliability. Then you have the model itself that needs to be monitored, and then the predictions, the output. So evaluate its output. So against grounded truth. So that in a way is kind of like a checksum of anticipated outcomes that can be revalidated against the system. And then with that, you have the whole idea here about that you need internal teams or processes as well that are looking here at continuously testing these with tools that are available here specific to AI. So not just traditional penetration testing or DAS testing, automated DAS testing, but there are also tools available for AI prompt injection type attacks that you want to use. So looking at the secure software development lifecycle. So here's a view of that and the different tasks, activities that happen within planning, creating code, verifying. You have your dynamic testing, your surface analysis, where you're getting ready for your penetration testing, right? You're going to do that pre-release as well, or user acceptance security testing, fuzz testing. In your planning, you have things like the design threat modeling for design risk analysis. You're going to use security requirements and frameworks and patterns and continuous training, etc. So looking at this type of model and framework standard that the organization has, you break down what happens within these. So in Agile application, you're going to do some design. You need to have some design diagrams here in the beginning to be able to start your development. You have to have an objective of where you're trying to get to. And then when you begin to develop your application, then you have these elements here that are in the design assessment phase, so the data sensitivity, etc. Now, when the security design happens, it's traditional security design review, but you also need to have now the AI-specific checklists as well being done to look at the architecture of the overall system. And again, under security and compliance testing, we have our traditional tools in here. But again, when we come down to these test tools as well, we want to make sure that it has AI prompt injection tools and methodologies being applied to it, going back to that attack chain as an example. And then when it comes down to continuous testing and monitoring, again, we have security events that we were logging as part of the design with security events in place. Now we need to add on to that as well the AI performance criteria and looking at how the drift and things may affect that from a security attacks through the AI model. The importance of the design review is to look at the assessing the security risk to the organization, looking at that based on the organization standards and requirements. Then you have the reduction analysis, which is the attack surface. So looking for potential weak spots and vulnerabilities in the design and looking at the privileges that are being used for the access permissions and things are using least privilege and using layered defenses wherever possible. So some amount of threat modeling also goes into play here as well. Identify the security vulnerability points within the design, determine what those risks and probability might be of those type of threats to identify what appropriate mitigations may be needed still for the design. Now, to help do that analysis, it's important to have the right kind of diagrams, the visual tools to be able to validate that. You don't want to just have verbal descriptions and will describe to me the application. We want to see actually what the design intent was that is being intended. So these are 5 design diagrams that every application should have anyway. So in Agile development, you're always going to be changing your approach. You're going to come up with an initial design concept, and you're going to iterate upon that based on the learnings from the code after it's released or the application. But you do have a starting point somewhere. So you still need things like process flows, which show the decision points and the processing logic that's intended. You have roles and permissions. Who's supposed to be using this, either as a consuming application or as users? What are their categories? What are the kinds of data that they should be able to see in the application or are barred from? Then you have the context of the application as a whole. This is the starting point. So the product owner should be able to kind of put together, what do they expect the system to be? Who are their customers, their end users? What is the functionality that they're looking for? What are the connection points, the user stories, and the users? And then you have the design as far as the data flow. How does the information flow between the system components? This could be the databases, the front-end web servers, whatever it happens to be that all tie all these things together, as well as going into the logging and the data layers themselves. So how do those elements all fit together, and looking at showing, well, do you have security at the communication layers? So typically looking for TLS 1.2, 1.3, that kind of thing is what you're looking for throughout the organization. And then the data map as well goes back to, okay, we know that there's different functions that the users are supposed to do. So what information is needed for that? Of the data elements that are going to be displayed in forms and being processed, which ones of those are PII, PHI, or financial information? The different categories of sensitivity. How are they being protected at rest? Again, in transit, you have here the connections being protected in that way. But in here, you want to know, well, for the design itself, are we using ES256 as an example for where the data sits? Or if you have some smaller IoT devices, an example, then you would have some of the NIST approved IoT encryption algorithms being used there. APIs, again, machine connections are a little different bird, but for the most part, it's the same kind of concept, same diagrams. You still need to know the roles and permissions of the applications that are allowed to speak to it. You also have the data sensitivity of what's being processed that's going in and out. But instead of a process flow diagram, usually sequence diagrams are more popular and meaningful. So those are the use cases, if you will, showing how the information is going to be processed and what it interacts with. So it's an input and output, but who is it speaking to and what are the transactions? And then you have the documentation. How are people to integrate and build with that? So this is an important part of the security. What is it revealing here about the application? And then you have the open API or Swagger documentation as well here that allows you to design, build, and validate the functionality of the application. So these are all elements, again, that should be easy to iterate off of. They can start off with what used to be called, back of the napkin diagrams, easily drawn in simple diagramming tools, Draw.io, Visio. Some people even use PowerPoint drawing. And then Excel for tables and using wiki tools, right? All of these things can be integrated. So these aren't meant to be heavyweight at all. So Agile development is not about documentation, but you still need to have valid design approach. So in analyzing the different design diagrams of the system itself, it's helpful then to put on the personas of attempted malicious actors. So there are various personas that you can use that are helpful here, showing what is their motivation and what are their objectives overall. So when you look at the diagrams, asking yourself here in your modeling, if I was a competitive spy and looking for organizational information, what can I get out of this system and what are the weak points? Or there's trolls, They just want to get in there and brag that they broke into the system and they messed up some of your information. But anyway, all these different elements, but a very important one as well to point out is disgruntled employee. So a lot of times the developers or the system administrators are all considered trusted individuals and highly professional, which for 98, 99% of the time is true, but how do you really protect against that as well? It should be part of the overall design, because even then a well-intended normal employee, if you will, or account can be manipulated and used. So overall, these are a way that the developers doing their own analysis of their system and the security tester as well of the design should look at these. And using then the methodology, STRIDE. So what are the objectives? So spoofing is about pretending to be somebody else. That's tampering with the data. Repudiation, claiming to be someone that didn't do something, performing illegal operations on the system, information disclosure. So these are all, again, just things that in the threat modeling and analysis, you use as different pieces of your analysis to kind of walk through the application itself. And then also using, say, the attack chains. And so here, that's where the MITRE attack matrix comes into play, is that if you just kind of play along, again, using this as a guide to looking at the application that's in front of you, trying to ask, well, is it which of these would it maybe be susceptible to? And then reading about the controls, knowing what the controls are, validating those that they're incorporated into the design to protect against them. In the software threat modeling, where that guidance as well, and here you want to look at those different areas, but then you're going to compare them to your own security code, security design review checklist. Again, one diagram, something like this, isn't really enough. It doesn't provide enough detail to be able to dig down into, well, how is the application going to be designed? How can it be switched or restored if the AI model becomes corrupted or the training data? The operations continuity, the business continuity without the AI model. So many companies have been totally brought to their heels when they have a ransomware attack because they don't have any other backup manual workarounds. Same thing kind of applies in an AI scenario, is that if you're unable to use that, or if the vendor pulled support for it or some strange event, who knows, especially like if you have SaaS solutions. So there have been some SaaS providers or PaaS providers that have gone bankrupt overnight. You know, what would that do for the application itself? The testing plan here itself, what does that look like? Then in the frameworks, what are those being used? And again, looking at access control, least privilege, not only of people being able to get to the model itself. So you're going to have a system diagram like this. You're going to put in here which control elements or threats there are. You can mark these all up as part of the threat analysis. Using traditional threat modeling tools, or you can draw your own using various UML drawing tools as well. So here's an example, for instance, provided through the OWASP documentation that shows an example here of a threat model, basic threat model example that's included with the top 10 LLM application guidance. So in the very final part here, there's a lot of content here. I realize that, and I apologize that wasn't able to get into all the details. Fascinating, but just wanted to provide a high-level overview. So let's look again, what are we trying to achieve overall? The main objectives of AI security is always going to be about continuous improvement. Same with all cybersecurity and application security. It all begins by looking at your governance, your culture of risk within the management and leadership, and what is specified for the organization as business objectives. It needs to be mapped here to what are the requirements overall within the organization that it needs to comply with. Then the measurement, how are the risks going to be identified, analyzed, and tracked? And then the management of the process itself, what is working, what isn't working. So going on to that, because these elements in here are all part of the NIST AI 600-1 document. But how can you begin that journey? Well, the first thing is awareness within the organization and yourselves about what the latest AI development risks and prevention guidance might be. So I have a newsletter, AppSec News Bits. So I share all the information that I come up with on a weekly basis, so it's not too much. It's not every day, if you will. On the other hand, there is a lot of information that's happening right now in this space every single week. There are many sources of information, so I'm just correlating stuff that I run across. Please use other sources of truth that you can monitor as well. I just offer that as one thing. But the main thing is to get awareness out within the organization to various developers and stakeholders in your organization about these concerns and developments. The next one is to take inventory of where you really are in the maturity matrix and that guidance. So overall, looking at application security as a whole, how's that practiced? Because that's fundamental. If you can't do that properly, you're going to be exposed to most of the AI attack scenarios. But then on top of that, then you need to be able to address the AI specific ones. So a way to use as a framework for that is the OWASP a software application maturity model. You can use that to do your own analysis and then compare that to your governance that you have within the organization, policy standards and requirements, looking at those being mapped to the NIST 853, the 218, and the AI versions of those, and the risk management frameworks, etc. Those other documents that we were talking about apply in there. Making sure as well that taking inventory of the SSDLC processes and execution that you have. Look at the whole attack surface of the whole organization. Don't just do an analysis of cherry-picked applications. I mean, we can all tell a happy story by grabbing one group that gets a lot of assistance, but really if that's 1% of your applications or 5% or whatever it is, right? It doesn't matter. Then it's really only providing a partial picture of the actual status of where you are. So make an inventory of where the maturity of the organization is, and then that'll help you set up a baseline for then further objectives of improvements. The other aspect is the governance requirements and risk management objectives. Monitor those, right? So what are the business objectives in your operations? And if those are disrupted, what are the financial risks that would be to the business? And those need to be quantitative. What's the financial impact of if a prompt injection were to get in there and disrupt our data, as an example? And then you're getting a feedback loop. What is that financial risk to the organization? Is that acceptable or not? That's an important aspect of helping prioritize these initiatives and being able to prioritize as well the amount of work. In the SSDLC, you want to shift left. It's cheaper to do stuff pre-implementation and pre-delivery. So start with the design reviews. That's where the threat modeling by a subject matter expert analyst is extremely important, not just a checklist of attestations, because a lot of times the person attesting doesn't necessarily know everything and they can be kind of rushed or they don't know how to answer the questions, so they put something down. But Or sometimes they answer with what they believe is correct, but the code is actually completely different. So, and the design. So make sure that that's being done in a correct manner. And also looking at the business continuity plans as well for if you do have an AI incident, not just a security incident, but an AI incident, and then what is the response design there for that. Role-based training, awareness, and education throughout the organization. And you can see here that in the last year, there's been a tremendous amount of compliance guidance changes that have happened, as well as attacks and the prevalence of the types of attacks. So it needs to be updated right now more frequently than once a year. Obviously, you can't have everybody go through a bunch of training and awareness every single year, but at least keeping that information fresh and available to the organization. But made specific to the organization's personalized, if you will, risks. What are the requirements that we need for our tech stack? What are the defenses that we have for preventing these? And what are the processes that we have in place? So all of that is information that's relevant instead of talking about, conjecture or what is going on in other organizations. And it's key that leaders and managers are involved in that awareness and education. Product owners, because they need to understand the financial impacts and the delivery impacts and the resourcing impacts that are required to support the products and their development. The developers themselves, again, AI tools are helping them to be able to develop some pieces of code quicker. On the other hand, there's more things that they need to validate and protect against. And then the testers, the complexity of the amount that they need to validate and verify is increased. So they need to understand what it is that they're looking for and to prevent. And continuous monitoring improvement, right? So reporting needs to be automated so that it can provide real-time dashboards, not something that's put out once a quarter, once a year, spreadsheets and PowerPoints as an example. These need to be automated in here, dashboards that are available for leaders, managers, product owners, and development teams so that they can see their slices, see how they are doing, and identify if there are any drifts that would be of concern that need to be addressed. And then automation tooling, looking at investing in those. So at the beginning of the whole AI, Gen AI hype bubble, if you will, the beginning of it, there weren't any tools. People were having to kind of make it up, but there are several startups and other companies that are all putting AI tools in place and adapting their tools. So there's quite a selection now of risk scanners for AI vulnerabilities, again, not just security, traditional vulnerabilities, and also the beginning of agents that can run the tasks necessary to monitor for security. So thank you very much. Again, a lot of information here. I apologize for that. But please reach out if you have any questions or comments. You can reach me on LinkedIn. There's the AppSec News Bits newsletter I mentioned as well that you can go take a look at on the web. And if you like it, you can subscribe to it. This presentation and some others are available as well on YouTube. And then the PowerPoint of these decks as well you can get through SlideShare. So thank you.